So one thing I wanted to clear up right now is, well, there's a few topics we've kind of glossed over that we probably should introduce at this point. One is the notion of type inference. So up until now, I've purposely been very meticulous about specifying the types for all the variables we declare. And this is just so that you have a clear sense of what you're doing and why you're doing it. In reality, though, in Swift, most of the time you don't need to because it's generally very inferable from the context, and Swift will make that call for you. For instance, if you wanted to say var x colon bool equals true, actually just by the fact you're assigning to this Boolean value, it knows that you're trying to create a bool. So you can just do this, and it's totally legal Swift syntax. It'll save you some typing. Same is true with integers. Interestingly, if you type in a decimal number, this actually doesn't get converted to float, but rather another type called double. A double is really just a slightly more memory intensive, but more precise version of a float. We don't have to worry about that too much right now. But suffice it to say, generally the type inference works very well in Swift, but there are some times you may need to, as you get more advanced, manually specify the types. We've just been doing that to make things really clear, and so that you know when you declare a variable, it must be of a certain type. But there you have it. That's the shorthand way, and in real code, you often don't see the type explicitly typed out because of this type inference. Another concept we've glossed over is that of constants. So a constant is very similar to a variable, except you know it's not going to change. Okay, so let me just rephrase that. If you declare a constant, it works the same as a variable, except that value can never change in the lifespan of that variable. So the difference is this. So let's just say we have this x, right? We can then assign it to false, and that's totally legal. However, if we create a constant, and which you do using a let statement, Swift will complain. Cannot assign to let value constant x. This is telling you that you're trying to assign to a constant, which is not allowed. Now, this is a simple concept, but why is it even in there? You know, it seems like a waste, right? Why would you take away power from the programmer? The point is that sometimes less is more, and in particular, there's two reasons. Probably the two best reasons are, first of all, as software gets more complex, you want to do all you can to really specify kind of the range of behaviors of code and the range of possible values of code, for instance. Constants are one way of doing that, because let's say you have a 1,000,000-line program and there are all kinds of modules. If you get a variable or value from somewhere and it's a variable, you're going to assume that that value can change. But if you get a constant, you know it's not going to change, and that can actually make debugging and writing error-free code much easier. I know it's a little hard to see now, but as you get into more advanced applications, just keep that in mind, that constants actually are a very powerful feature in languages because they reduce the complexity that the programmer has to worry about. And the other main reason is, not only does this reduce complexity for the programmers, but constants also reduce complexity for the compiler. So the compiler is the thing that converts this, programmer readable code into binary code that the CPU understands. So the compiler will actually be able to make all kinds of optimizations. If you can say that some variables are actually not variables but constants. So those are kind of two good reasons why constants even exist, even though right now, admittedly, it may seem kind of silly. Okay, so now that I've talked about those two things, gotten them off my chest, it's time to move on to some really powerful features. One of them is the collections data types. So collections represent a range of new data types we haven't looked at yet that are extremely powerful. And let's just start off with array. So an array is an ordered list of values of the same type. So say you had a bunch of medical records, right? You may store them in a list depending on your application, or a list of names. List of ordered values of the same type is a very powerful data structure to have. Let's take a look at how you actually declare one. So let's say you had a list of classmates. So to properly declare this, you do the square bracket, and then the type, for now let's use string, and square bracket equals square bracket, and then you start listing the strings that you want in your array. So we have 3 elements in our array now. Okay. And to access values in the array, you go with a square bracket and then the index of the element in that array. So which place in line are you trying to pull from? So since we know that this array has 3 elements, we actually know that the range of possible indexes is 0 through 2, because all array indexes start at 0. So Jason is at position 0, L's at position 1, Fred's at position 2. And we can confirm that. Jason's there, L's there, and Fred is there. Okay? There's some attributes of arrays that are very powerful. We can look at is empty. This is actually a Boolean that is returned. And so this allows you to test whether or not that array is empty. And so for instance, you may put this in an if-then statement and do something differently, right? You also sometimes want to know the count, which tells you how many items are in that array. You know, certainly we know that in this case it's 3 because we can see it right there, but in different applications you might not know that. So what else can you do to arrays? Well, right now we just have the static array sitting there, but actually you can add to arrays as well very easily. You can append, which adds something to the end of an array. And you can remove, looking at these different functions, you can remove all, remove last, which will just remove that last element of the array and return it. There's a lot of other functions you could look at, but those are kind of some of the main ones, and you get an idea of what it might be useful for.